Hey folks, Mike Johnson here. If it's got wheels and an engine, you're in the right place. On this channel, we dive into car repairs, maintenance tips, and everything you need to keep your ride running smooth. If you're into cars and want to keep learning, don't forget to hit that like button and subscribe. It really helps the channel out. All right, enough talking. Let's get into it.
In reality, the suspension system has an enormous amount to do, and the components have to bear an enormous amount of stress compared to the other major systems in a car. The suspension system is located between the chassis and the wheels and serves many important purposes. Ideally, a well-tuned suspension will absorb bumps and other road imperfections so that the people inside the car can travel comfortably. While this is very important from a passenger's point of view, the driver will notice certain other attributes of the suspension system. This system is also responsible for keeping the wheels on the ground as much as possible. How the suspension system works. Wheels are extremely important for vehicle performance and safety. Wheels are the only part of a car that touches the road. This means they have to put power to the ground and steer simultaneously, while also being responsible for stopping the vehicle. Without a system to absorb the bumps and potholes present in roads, the vehicle would shake and wobble on a rough surface and render the vehicle essentially unusable for lack of traction. While the suspension system is an excellent solution for bumpy roads, it adds a great deal of complexity when you consider that the wheels are now responsible for all their standard duties and must now move up and down to absorb the shocks caused by bumps. The vehicle behaves as if it were not on springs and being tossed about at every turn. That's why the suspension system is so complex. There are many parts involved, and a single broken or bent part can sabotage the whole setup. How does the suspension system work? Most modern cars have independent front and rear suspension, allowing each wheel to travel independently of the others. However, some cars use a more basic beam axle due to lower costs and simpler design. The only beam axles still used in new cars are live axles. Live axles have a powered wheel at each end, and dead axles have freely rotating tires at each end. The problem with rear tires that don't move independently is that they always keep the same angle to each other rather than to the road surface. This means less traction and less predictability in handling. Until the latest iteration, the Ford Mustang used a real axle and received heavy criticism for sacrificing performance for nostalgic handling. Beam axles also contribute to unnecessary unsprung weight. Unsprung weight is weight that does not rest on the suspension. Weight resting on the suspension is called sprung weight. Having low unsprung weight relative to sprung weight makes a car feel lighter and livelier. The opposite provides a harsh ride and a feeling of having less control over the vehicle. If the energy differential transmitted to the wheels via the axles is attached to the chassis or body of the car rather than to the axle itself, then there is a significant amount less unsprung weight. This is a big reason, in addition to the many other advantages of having one wheel able to move without greatly affecting the other. Wheels. Why independent suspension is almost universally adopted by carmakers for the front and rear wheels of their vehicles. The independent front suspension allows each front wheel to move up and down with the spring and shock absorber bolted to the frame at one end and a control arm or wishbone at the other. A control arm is attached to the front of the vehicle near the center at one end of the arm and the steering knuckle at the other. A triangle does the same thing except that it attaches to the frame at 2 points, making the part look like a triangle. The positioning of each component in independent front suspension systems is very important, as the front wheels must guide and maintain constant alignment to ensure safe vehicle operation. Independent rear suspension uses the same technology as the front, without taking steering dynamics into account, as the rear wheels generally do not steer. Rear-wheel and all-wheel drive cars have a chassis-mounted differential in the middle of the suspension arms or wishbones, while front-wheel drive cars have a very simple rear suspension, requiring only springs and dampers. Shock absorbers and springs provide all the damping and compression when the suspension moves. Springs provide force to hold the suspended weight of the wheels and resist compression. Shock absorbers are oil-filled cylinders that force the suspension to compress and decompress at a constant speed, preventing the springs from bouncing up and down. Modern shock absorbers, or dampers, are velocity sensitive, which means they are softer when it comes to light bumps and more resistant to big ones. Think of springs as watchdogs, ready to viciously defend the car against bumps. Shock absorbers would be the ones on the guard dogs' leashes, making sure they don't take the job too far and do more harm than good. Many cars, especially small ones, use McPherson struts which sit in the center of a coil spring and act like shock absorbers. This saves space and is lighter too. How does the suspension system enhance passenger comfort? When the ride or comfort of a car is good, it means that the suspension has good road isolation. The suspension is able to rise and fall as necessary without jarring the vehicle. Just enough road feel reaches the driver, so they'll know about alarming road conditions and feel a rumble strip if they enter the shoulder of a high-speed road. Older luxury cars, American luxury cars to be precise, have a reputation for having such a plush suspension that the driver would feel as if they were driving a boat. This is not optimal, as feeling the road, at least a little, is essential to maintaining situational awareness while driving. Often, factory-tuned sports cars and compacts are criticized for their poor road isolation. The manufacturers of these cars assume that their demographic seeks fast single-lane lap times above road comfort. What's more, vehicles on the racetrack are increasingly subject to aerodynamic downforce, which could make the highway-oriented suspension unpredictable, especially when cornering. Some possible problems with the body or ride to watch out for include a body roll, or when the car's body leans outward in turns. All cars do this to some extent when turning into a corner, but if the car's body rolls too much, the change in weight can cause the vehicle to spin, pull away from the corner prematurely, or lose traction on one or more wheels. Bottom out, or when the tires hit the body of the car when the suspension is compressed. This happens when the car doesn't have enough suspension to absorb the force of the bump it's traveling over. Stop blocks can prevent this by providing a cushion between the suspension and the frame that prevents the tire from rising high enough to hit the car's body, but if they are inadequate or missing, then this problem can occur. Depletion can easily damage the body, wheels, or suspension system. How does the suspension system help the car stay connected to the road? A car's handling ability is measured by the extent to which it can maintain good traction and even weight distribution when different forces are involved. To feel stable at a standstill, a car needs a suspension that doesn't let the front end dive when the brakes are applied. For smooth acceleration, a suspension that prevents the car from crouching at the rear when the throttle is open is needed. Variable weight gives half the wheels most of the traction, wasting power, and causing inconsistent handling characteristics. As mentioned above, body rolling too much into corners is bad for handling. Body roll is also bad as it shifts traction to one side of the car more than the other by rounding a corner. This leads to a loss of traction from the inner tires and perhaps even leaves the road surface. A suspension that ensures good road holding will prevent this for the most part. Some traction problems that can be attributed to a less than ideal suspension system include a bump steer, or when hitting a bump causes the car to turn left or right without the driver turning the wheel. Suspension misalignment can cause the wheels to lean at an angle that causes this problem. Oversteer, or when the rear of the car loses traction and pulls away, rounding a corner. If the body rolls too much in corners, the change in weight can cause the rear wheels to lose traction. The fact that the rear wheels form an angle that doesn't allow the tire to stick to the road when cornering can also cause this problem. Understeer, or when the front wheels lose traction when rounding a bend and the vehicle drifts to the outside of the bend. Similar to oversteer, excessive roll, or poor wheel alignment can lead to poor front wheel traction when cornering. Understeering is particularly dangerous because front-wheel drive cars steer and provide energy with the front wheels. The less traction the front wheels have, the less effectively the car can steer. Both oversteer and understeer are exacerbated by slippery road conditions. Suspension maintenance. Since the suspension system's main job is to absorb shocks in order to protect the vehicle and its occupants, the parts are built to be fairly durable. There are a few other components on modern vehicles that are just as over-engineered as those found in the suspension system. However, with so much movement and force in the suspension, parts inevitably wear out or become damaged. The most severe potholes can even lower the car so hard that the towers holding the springs in place bend or break. Squealing noises usually accompany bushing and other connections fail. If any corner of the vehicle becomes too bouncy as you drive over bumps, have the shocks or struts inspected immediately. Suspension-related problems need to be resolved immediately, so if a vehicle's handling or shock absorption changes, have it inspected as soon as possible. In conclusion, understanding how the car suspension system works is essential for appreciating the intricate balance between comfort and control in vehicle performance. By absorbing shocks, maintaining tire contact with the road, and ensuring stability during turns, the suspension system plays a crucial role in enhancing both safety and driving experience. Whether it's through springs, shock absorbers, or various other components, each part works together to provide a smooth ride. As you drive, remember that this complex system is constantly at work, making your journey not only more enjoyable but also safer. Thank you for watching, and we hope you gained valuable insights into the fascinating world of car suspension systems.